right, so let's continue our lesson on completion of squares. There's so much sound. So completion of squares. Already we've spoken about how to use the factorization method to solve some quadratic equations. However, we need to stop. Alright, so we said the last time we spoke about how to use factorization method to solve some questions involving quadratics. And this time around, we would want to use another method called the completion of squares. Since some quadratics cannot be factorized. And secondly, too, we have to use completion of the square as a technique to express our equation in other form called the vectors form. Hello, hey, pay attention. Into other forms called the vectors form that we can use to derive other features of the graph. Are we following? All right, so when I have something like this, x squared plus 2x minus 15 is equal to 0. I would want to first of all group like terms. So I'll have my x squared terms here plus 2x is equal to positive 15. And like we mentioned previously, completion of squares or the idea of quadratics is more of putting things into shapes, the square shape or quadrilaterals basically. So if I have this, I can relate this to various, I can express these things as areas of various shapes. So therefore I can have a shape like this. So if the area is x squared, what will be each side? What will be the length of each side? That will be x. Yeah. Don't worry, just pick it up. So that will be x. So we have x squared. And I'll have another one like this. The bouncing is not helping. I have another area like this. Here will be x. Here will be 1. And here will be 1 as well. Are you following? So you have x squared plus 2x as an area. And it's going to be equal to another area here, which is going to be 15. So I could decide that I want to bring this one to the various edges. So if I take something like this, I can lift this gently and put it over here, and lift this other one and put it here as well. I'll be asking you to explain the same thing. No? So we'll have this. I'm going to lift it and put it over here, lift this and put it here as well. So I have something like this. Just lifting this and putting it at this side. And then I can take this other side as well, put it here. So this is gone. The whole of this is gone. All right, so I'll have nothing here. So after this arrangement, I would want to just quickly take your seat. I would want to make this thing to be a square. What value do I add to this side to make the square complete? What value will I add? Yeah, Calvin. Yeah, I can add 1. So now I can add an area of just 1 to this side, and then I've completed the square. So, but then when it comes to equations, whatever you do to one side, you do the same thing to the other side. So I'll introduce 1 to this side as well. So plus 1. And if I do that, it means that I'm going to have something like this. To this other side. Then what does this area becomes finally? Becomes 16. And then since this is x, this is 1, this is 1. So I can say that for this side as well, if it's 16, what are the likely possibilities of these two sides? It could be 4 minus 4. So I can either have 4 giving me 16 as the area. I can also have minus 4, this is giving me 16. So having done that, I can therefore say that x plus, if these two sides are the same, then x plus 1 can be equal to what? 4. Or x plus 1 can be equal to negative 4. So I would have x to be equal to 4 minus 1, giving me x equal to what? X will be equal to 3. Or x equal to minus 4 minus 1, where x will be equal to, it will be equal to minus 5. Minus 5. So it means that the two values for x will be either x will be equal to 3 or x is equal to minus 5. Now let's try another example and then we'll come up with a rule for that. If I have a question like x squared plus 4x minus 21 equal to 0. If I'm grouping those terms, I want to just take the constant term to the other side. I have x squared plus 4x equal to what? 21. And if I have to represent this graphically, since we are looking at the areas of this algebraic expression expressed as area, I'll have something like this: x and x plus something this way. I have some 1, 2, 3, 4. And I'll have this length to be x, and this size will be 1, 1, 1, and 1. Is that okay? So let me bring it down a little so I can place them around. If I now want to arrange this around this, so that I have just one part to create my perfect square, I will have something like this. Don't mind the shape that much. I mean the area drawing. I'm not drawing to scale. So I'll have let's arrange them around it. 2, 2 at each side. 1, 1, 2, and then this other side as well. Let me just clean this part a little to just represent the square well enough. So I'll have this equal to this other area here, which is also just 21. Okay, so how much will I add to this place? What area should I add to this place to complete it? That will be, we'd have 1 here, another 1. This space are 1. So this is 1 squared, 2 squared, 3 squared, and then how much? 4. We need to put 4 squares here. Yeah. So therefore, I would have this side to be x. If here is x, this will be what? 2. X and then 2. Is that okay? Then if I'm introducing that same amount, I'm introducing 4 here. We actually have 21 to begin with. And if I'm introducing 4, let's take something like this. 4. Yeah. 2, 3, 4. You wouldn't see the shape expressly, but the concept is still clear enough. All right, so here, what do I get as a total area at this side now? 25. Good. So I can therefore say x plus 2 equals to, if it's 25, then two numbers can square to give me 25. What are those numbers? 5 and then negative 5. Okay. So I can therefore say x plus 2 is equal to 5, or x plus 2 is equal to negative 5. If x plus 2 is equal to 5, what will x be? X will be equal to 3. If x plus 2 is equal to negative 5, what would it be? What will x be? X will be equal to negative 7. So we've been able to graphically explain where the concept of completion of squares is coming from. Now, let's see if we can see a certain trend in what's happening. It looks like, what's unique about this in relation to this guy? Can anybody observe something obvious? This is what? Relation between this and this. Okay, let's introduce this one here, plus 4. And then plus 4. This is what? You are saying something? This is what? Half the square of the coefficient of the x term. Do you get that? So you have the square of the coefficient of the x term, and then you get this. You get the number you introduce to complete the square. So what's half of 2? 1. 1 squared. Half of 4? 2 squared. So in completing the square, you need to add half the square to both sides to get your answer. Do we get that? So let's try this example and see how it's going to work. So let's have x squared plus 5x plus 6. Now this time around, we are not going to draw all of this again. We'll just quickly use the concept we have derived to solve this. So that would mean that I have x squared plus 5x. I send the 6 to this side. Now, what is half of 5? Half of 5 is what? 5 on 2, right? Okay. So plus 5 over 2 all squared. So I'm adding half the square of this to complete the square. Plus 5 on 2 all squared to both sides. Now, if I have this, I would want to express this thing to look something similar to what we have here. So to write that, I'll have x plus 5 over 2, they have the square term, which is x plus 5 over 2 all squared. So this is another way of writing this. Would be equal to, what do we get from here? Minus 6 plus 25 over what? Over 4. Okay. So I'll have x plus 5 on 2 all squared. What's the answer for what's happening here? You say 1 over 4. So 1 over 4. Now, if I'm finding the square roots of both sides, here, of this. Now, you know that I have to quickly introduce. What do I put here? Exactly. So plus or minus root of, or basically 1 over 2. That's good. From this side. Okay. So I'll now have x 2 be equal to minus 5 over 2 plus 1 over 2, or x can be equal to minus 5 over 2. Let me color code this well, just so that I can appreciate it. 1 over 2 minus 5 over 2 minus 1 over 2. And what are the values for this? The first one will be what? Minus 5 over 2 plus 1 over 2 becomes what? 4 over 2, and ends up minus 2. Okay, so it becomes minus 2. And this part, minus 6 over 2 minus 3. I hope you get that. So basically, this is how we complete the square. We'll solve other examples to see how it's done in other questions. So that's it. We'll move on to solve some other questions and then appreciate it.